Alright, welcome back. My name is Isaac, and today we're going to be going over section 3.9, which is inverse trigonometric functions, and learning how to take derivatives of them and how to work around them. So, before I even hop into the derivative side of things, just a little trig review is going to help here. So, this is like problem number 2 here. It says it's giving us something to compute. It's sine of the arc cosine of root 23, sorry, the pen's going dead, root 23 over 5. Alright, so how do we deal with this? Well, the first thing to realize is that on your homework, you're going to see arc cosine of something written as cosine with a -1 of that something. Just like we used, for f prime of x, if we wanted to indicate an inverse, we did f minus 1 of x. That's the inverse of f of x. So they're following the pattern here. Personally, I prefer to write out arc cosine. Not that it really matters as long as you are consistent with what's going on. But one of the things that bothers me is, like, for example, if I have x to the -1, I could write that as 1 over x. And here's where the problem is that cosine minus 1 of theta does not equal 1 over cosine of theta. In fact, 1 over cosine of theta equals secant of theta. So if you're going to use the -1 notation like my math lab, just be careful that you don't think you can do this algebraic trick, because it doesn't work for arc cosine or arc sine. It does work for secant. You can write secant as 1 over cosine, but cosine inverse cannot be written in this way. So now that I've got that out of the way, back to the problem at hand. So, how do we deal with these arc functions inside of other functions when they're trigonometric? Well, the first thing to remember is SOHCAHTOA, because remember sine, cosine, and tangent in every other trigonometric function is a ratio of right triangles. And what I mean by that is if I draw a right triangle like this with angle theta, if I'm looking for the cosine of theta, that is the ratio of the adjacent over the hypotenuse. The adjacent over the hypotenuse. The adjacent is square root 23. The hypotenuse is 5, because adjacent over hypotenuse. So there's the first part, as I figured out this is adjacent over hypotenuse. And now I'm going to look on the outside of my function where it says sine. And sine, if you recall, is opposite over hypotenuse. So to solve for this problem, we're going to need to solve for the opposite side of this right triangle. And so what we'll do is you could label it x or some variable. And we know that x squared plus 23 squared is going to equal 5 squared using Pythagorean's theorem. And so now that we're there, we end up with x squared plus 23 equals 25. We'll subtract 23 from both sides, and we end up with x squared equals 2. And then we'll take the root of both sides, and we'll end up with x equals square root 2. Thus telling us that the opposite side of this right triangle is the square root of 2. And so then what we do is to solve this is we write out what the opposite is over what the hypotenuse is. And the opposite here is root 2, and the hypotenuse is still 5. And this is how we deal with these arc functions within functions, or inverse functions within functions. I would like to go over just one more for good measure. Trig tends to be one of the things that really makes people struggle, self-included. So it's really important in calculus to have a good understanding of trig. Alright, so if I have tangent of the, I'm going to write it the way they do, of the inverse sine of negative root 2 over 2. Now remember, we could write this as arc sine instead of sine to the negative 1. And so what we're going to do here is we're going to say, well, I know sine's opposite over hypotenuse, and tangent is opposite over adjacent. So I start out by drawing my triangle with the information within the arc sine. So I draw my triangle. Here's my reference angle theta. I've got opposite, or root 2, over hypotenuse, which is 2. And mind you, there is a minus sign here. That minus sign will strictly depend on what part of the unit circle you're in. And so for now, I'm just going to ignore it. So to solve for this side, we could label this side x. We could say x squared plus root 2 squared equals 2. And so then what we can do is we can, no, wait a second, that can't be right. Opposite over hypotenuse. Alright, so sine is opposite over hypotenuse. 2 squared, there we go. So we've got to square all of our Pythagorean sides. And what that'll give us is x squared plus 2 equals 4. Subtract 2 from both sides. And we find that x squared equals 2. We take the root of that and find that x equals 2. So, or square root of 2 rather. X equals square root of 2. So the opposite, or the adjacent side of the triangle is root 2. And that makes sense, right? Because root 2 squared plus root 2 squared is 4. Take the square root and you get 2. So that kind of makes sense. Alright, so we know that now we know both of our opposite and our adjacent and hypotenuse. To do tangent, you have to know opposite over adjacent, which we do now, which happens to be root 2 over root 2. And that is going to give us 1. But we have to remember something, which is that we were given a negative value for the opposite. So this is actually in the fourth quadrant, and so I believe this will be a negative 1. And that was correct. So definitely be careful about your minus signs. Also, you may want to refresh yourself on the boundaries, or I don't quite remember what they call them. The boundaries of the trigonometric functions. For example, tangent is in between negative pi halves and pi halves, whereas sine and cosine are from 0 to pi. So anyways, I'm thinking at this point of cutting this short and doing a part 2, because I really wanted to cover some of the trig techniques that you'll need to be using. In next video, we'll start with the derivatives.